Hey, welcome back. This is Math 1530, College Algebra, and today we want to work with polynomials and rational inequalities. Okay, tons and tons of uses for these things later in math, so we want to get them on the books. Okay, so first we'll deal with the polynomial types. So polynomial inequalities. And let's just take a look at an example. Okay, so solve, and then we want find the solution set. So solve and find the solution set. Right, so they give us their inequality, 2x squared plus x is greater than 15. So the first thing you want to do is get 0 on one side. So here we go. I'm going to move the 15 over. So I have 2x squared plus x minus 15 greater than 0. The next thing I want to do is kind of forget about the inequality for a second and just work with this set equal to 0 and solve it. Right? So instead of inequality, just set it equal to 0 and solve. Okay, so I think I can factor this guy. And it will be 2x and x. It's got to be plus minus, right? So 3 and 5 probably, with the bigger guy ending up being positive. Okay, so when I go 3 times 2, the outer will be 6. Minus 5x will be plus 1x. Okay. Then I'll solve for those two zeros. And the other guy. Okay, so far so good. Now comes the sort of different part. I'm going to draw a number line and then plot those 2 points on the number line. So you don't have to draw in all the numbers. I'm just going to make sure I have them in order. Okay, so 5 halves and negative 3. Then what I'm going to do is test value. And the test value will give me a sign of the function on that interval. And then I'll make a conclusion based off of that sign. Okay, so for my test value, I'm picking a number in this interval from negative infinity to negative 3. Okay, so I'll pick something like x equals negative 4. Okay, all I need is the sign of the function in that interval. It'll always have the same sign in that interval. So all you need to do is plug negative 4 into the equation, and you can actually use this factored form down here. If you plug negative 4 into there, you'll have 2 times negative 4, which is negative 8, minus 5, which is going to be something negative, right? And then negative 4 plus 3 is negative. So you're going to end up with a negative times a negative, which is positive. Okay, so I don't care about anything except the sign. Okay, so my conclusion is that in that part of the graph, the graph is above the x-axis. In other words, it's greater than 0. Okay, so my conclusion in that interval, it's greater than 0. Okay, so if I were to graph it, the thing would be above the x-axis. Okay, so let's find another test value in between negative 3 and 5 halves now. So I'll pick 0, right? If you plug 0 into back over here, you'll have 2 times 0 is 0 minus 5, that's negative. And then 0 plus 3 is positive. So a negative times a positive is negative, and that means it's below the x, it's below 0. So it's less than. Okay. And the final interval, I'll pick something like, I don't know, 3. And if I plug that in, I'll have 6 minus 5 is positive, 3 plus 3 is positive. So positive times a positive is positive. It'll be above the x-axis, so it'll be greater than 0. Okay. Okay. Now I need to pick the intervals where the thing is greater than, because of the original inequality right here. Okay. I'm looking for those intervals. Those are going to be the x values that satisfy that inequality. Okay. So I find the ones that are greater than. It's this interval and this interval. Okay. So my solution set will be the union of those two intervals. So I'm going from -infinity to -3, and you don't include that because of the inequality type. If it was a greater than or equal to, you would include -3, but we don't because that's where it would be equal to 0. Okay, and then union with 5 halves to infinity. And again, we're not going to include the 5 halves because of the inequality type. Okay. So if there was a line underneath it back over here, this inequality type, it tells us to use parentheses. If there was a line underneath, we'd use a bracket. Okay. Okay. So let's just try another one of these, and hopefully. Okay, so let's try another one. This time we'll have a line underneath. So 3x squared plus 16x less than or equal to -5. Okay. Okay, it's the same procedure. So first get 0 on one side. So I'll have 3x squared plus 16x plus 5 less than or equal to 0. Okay, so I just added 5 to both sides. Now I want to kind of just set it equal to 0 and find, and they call these, I think, the boundary points. Okay, these are the boundary points. So, you'll have 3x and x, and it looks like we're going 5 and 1, and then it has to be plus plus. Okay. So I have 3x plus 1 is 0, and then x plus 5 is 0. So 3x is -1, and then x is -1/3. Over here, x is -5. Okay. Once you get those, you plot them on your number line. So -5 is to the left of -1/3. Then you're going to get your test values, your signs, and your conclusions. Okay, so let's try it. My test value, I'm picking something from -infinity to -5. I'll pick -7. And I'm plugging that into this expression here. I boxed in red. So -7 times 3 is -21, plus 1 is a negative. -7 plus 5, that'll also be a negative. Negative times negative, positive. So it'll be greater than 0 in that interval. In the middle interval, let's try x is -1. Plugging it again into this red box. -3 plus 1 is negative. -1 plus 5 is positive. Negative times positive is negative. Okay, so it'll be less than 0 in that interval. Finally, we could pick 0. It's always easy. Plug it back into this box. 0 times 3 is 0, plus 1 is positive. 0 plus 5, positive. Positive times positive, greater than. Okay, so this time, because of the inequality type, we're going to be using brackets, okay, as opposed to the open parentheses. So we need the intervals that are less than, so we'll take this interval, and on the ends we use brackets. So the solution set will be -5, including -5, to -1/3. Okay. Okay, let's try one more. Well, actually, let's move on to the, well, no. Okay, we could try one more. Let's take one from the, do I have the web set up? No, I don't. Sorry. Let's see if I can. Okay, let's look at something from WebAssign. Here's one. So we have 2x squared minus 7x less than -5. So we'll be using open parentheses as opposed to the brackets in our solution. Again, you got to set it equal to 0. So you'll have 2x squared minus 7x plus 5 less than 0. And then set it equal to 0. Okay, so 2x squared minus 7x plus 5 is 0. and then we want to factor it. Okay, so we'll have 2x, and it looks like it's minus minus, and x minus, and then 5 and 1 equals 0. And then we'll be able to get the zeros. So 2x minus 5 is 0. 2x is 5. X is 5 halves. And then x minus 1 is 0, so x is 1. Then you go to your number line and plot your points. So 1 is less than 5 halves. And then you need your test values, your signs, and your conclusions. Okay. So in this case, we are looking for conclusions that are less than. Okay. So anyways, let's try some numbers. So test value x is 0. I'm plugging it into this box. So 2 times 0 is 0, minus 5 is negative, 0 minus 1 is negative, times negative is positive. Conclusion, that one is greater than. Try x is 2. So 4 minus negative times positive is negative, so that'll be less than. Try x is 5. 10 minus 5 positive, 5 minus 1 positive, positive, positive. It's greater than. So the interval we want then is this interval. And because of the inequality type, there's no line underneath. We're going to say our solution set is from 1 to 5 halves. Okay? And that would be it. Some of these problems, they kind of already have them factored for you. Let's see if I can find one. Well, not really. It seems like some of the ones I did were oh yeah, so here's one that's already kind of factored. So that means half the work is pretty much done for you. So if you have an example like this, x times 4 minus x times x minus 6. And then we are less than 0. Okay. So in that case, it's kind of already done. You're just you get x is 0, x is 4, and then x is 6. Go to your number line. 0, 4, 6. You need your test values, your signs, and your conclusions. And so we'll try x is negative 1. Negative. So there's negative times positive times negative. Negative, positive, negative is positive. So that'll be greater than. Okay. Try x is 1. That'll be positive, positive, negative. So that's a negative, that's less than. Try x is 5. That'll be positive, negative, negative. So that's plus. That'll be less than, or greater than, sorry. And then finally, x is 7. So that'll be positive, negative, positive. So that'll be negative, less than. Okay. And again, the inequality type this time means that we're using parentheses as opposed to the bracket. Okay. And we're looking for the less thans. Okay. Okay, so we're going from 0 to 4 and unioned with 6 to infinity. Okay. Let's make sure that's right. 0 to 4, 0 to 4, and then use the union button. Then what did I say? 6 to infinity? To infinity. Let's see if that's right. Yay. What else do they want to know? Oh, they want you to graph the thing, so we already graphed it. It's just these two intervals in here, right? This interval, and then this interval. Okay, so there should be a small open one, and then another open one, so this part C here. Let's check it. Yay! All right. Same sort of spiel here. So we have 3 minus x squared times x minus 7 halves. And then that's less than 0. Okay, so less than 0. So again, this one's kind of done for you. You're setting 3 minus x squared times x minus 7 halves equal to 0. So 3 minus x equals 0. It's a repeated root, but that's not going to mean that we have any extra work to do. You're just going to label 3 on the number line. X minus 7 halves is 0, so x is 7 halves. So 3 is less than 7 halves. And do your test value, your sign, and your conclusion. I think the deal with this one is it's not necessarily going to be the case that you always go plus minus plus or minus plus minus plus minus plus. It's not always going to alternate on you, especially if you have something like a repeated root. So if you do x is 0, you'll get 3 minus 0 squared. Anything squared is positive. So this first part here is always going to be positive. Then you put in 0 minus 7 halves, that's going to be negative, so you're less than. Okay. Try x is 4. Okay. That first term will always be positive. And the second term is going to be 8 halves. It's 4. Sorry, that is not in between 3 and 7. So 7 halves is 3.5. So I can't use 4. It's not in there. I have to use something like 3.1. Okay. So if you put 3.1 in there, 3 minus 3.1 is negative, but when you square it, it's positive. And then 3.1 minus 7 halves, okay, is also going to be that's going to be negative, right? Because 3.1 is less than 7 halves. So positive times a negative is negative, and it will be less than. Okay. Then at 7 halves, over that, so something like 8, I don't know, positive 3 minus 8 is negative, but a square is positive, and then 8 minus 7 halves is positive, so that would be greater than. Okay. So in this case, it's negative, negative, and then positive. We are looking for the inequalities that are less than, and we can't include 3 because that's where it's equal to 0. So we kind of have to be a little bit careful to exclude 3 in our solution set. So we'll have negative infinity to 3, and then union with 3 to 7 halves. Okay, let's make sure that's right. That seems just so weird that it can't be right, right? So negative infinity to 3, and then union with 3 to 7 halves. Oops. 3 to 7 halves. Okay. Yay. All right. So on the number line, it looks like it's going to be B, right? Yay. Okay, so that's one type of problem you're going to see. The second type of problem are the rational inequalities. Okay. So solving rational inequalities is similar, but there's some extra stuff we have to worry about. Okay, so let's look at an example. We have x plus 1 all over x plus 3 greater than or equal to 2. So just like before, you need to get 0 on one side. So we're going to move the 2 over. So that part's the same. X plus 1 all over x plus 3 minus 2 greater than or equal to 0. This next part then is a little bit of work. You have to combine these into one fraction. Okay, so I'm going to need a common denominator on that second term. Negative 2 is the same as negative 2 over 1. I'm going to multiply top and bottom by x plus 3. Okay, so I have x plus 1 minus 2 times x plus 3. and that's all over that common denominator that I just figured out, x plus 3. And that'll be greater than or equal to 0. And then you simplify, so you'll have x plus 1, I have to distribute, minus 2x minus 6 all over x plus 3, greater than or equal to 0. And then you have then negative x minus 5 all over x plus 3, greater than or equal to 0. Okay. At this point then, you're going to set the numerator and denominator equal to 0, and those are going to be your boundary points. Okay. So I'm going to take negative x minus 5 set it equal to 0. I'll get x is negative 5. And I'm also going to do the denominator. So I take x plus 3 and set that equal to 0. And I get x is negative 3. Okay. Okay. Then I'm going to plot those 2 points. So for the numerator, if you have greater than or equal to, you're going to include that point. Okay. If it was just greater than, you would not include that point. So for negative 5, it's kind of a reminder, I'm going to include it. I'm going to put a closed dot there. And then for negative 3, you never include the 0 from the denominator. Okay, so you're just going to put an open dot there. Then everything else is the same. It's the test value, the sign, and then the conclusion. Okay. Okay, so I'll try x is negative 8. And I'm plugging that into this expression I just boxed in red. And again, all I care about is the sign. So negative 8 is positive 8, minus 5 is positive. All over negative 8 plus 3 is negative. A positive divided by a negative is negative. So it's less than. I'll try x is negative 4. Negative 4 is positive 4, minus 5 is negative. Negative 4 plus 3 is negative. Negative divided by negative is positive, so it'll be greater than. Then I'll try x is 0. Negative over a positive is negative, so it'll be less than. Okay. And I'm after inequalities that are greater than. So I need this middle inequality. And then you use a bracket if you have a closed dot and a parentheses if it's an open dot. Okay. So in this case, my solution set, I'll write in white, my solution set is bracket negative 5 to negative 3 open parentheses. Okay. Okay, let's look at one more of these. 1 over x minus 3 less than 1. Okay, so again, I got to set it equal to 0. 1 over x minus 3 minus 1 less than 0. I need a common denominator. So 1 is the same as 1 over 1. Multiply top and bottom by x minus 3. Okay. So I'll have 1 minus the x minus 3 all over the common denominator, x minus 3, less than 0. Okay. I want to distribute the negative here. So I'll have 1 minus x plus 3 over x minus 3, less than 0. Then I'll have 4 minus x over x minus 3, less than 0. Okay, now I need to set the numerator equal to 0. So I'll have x is 4, and the denominator equal to 0. So I'll have x is 3. So again, if your inequality does not have the line underneath it, you're going to use an open dot. Okay, so if you have this or this, you use an open dot. If you have this or this, you're going to use a closed dot. Okay, to remind you that the open dot means a parentheses, and then the closed dot means one of the brackets. Okay. For the denominator, this part is for the numerator. For the denominator, you always use open dot. So you never include it in your solution set. So on our number line this time, both of them are going to end up getting open dots. So 3 is less than 4, so there's 3, there's 4. I'm going to use open dots, so both of them are going to have parentheses. Okay, so back up here, because of the inequality type, because we had that greater than or equal to, we use a closed dot for -5. And then -3, always use, for the denominator, you're always using an open dot. You never include it. So in this case, we had greater than or equal to, and that meant or means use a closed dot. Okay. So getting back to this problem, now we're doing our test values, our signs and conclusions, and I'll try x is 0, and again I'm putting them into this boxed expression. So 4 minus 0 is positive, over 0 minus 3 is negative, positive over negative is negative, that'll be less than. Let's try 3.5. 4 minus 3.5 is positive. 3.5 minus 3 is positive, so that will be positive, greater than. Try x is 5. 4 minus 5 is negative. 5 minus 3 is positive, that will be negative, so that'll be less than. And we are looking for this less than inequality type. So it's this interval and this interval. Okay, so our end solution set is going to be -infinity to 3, don't include 3, and then union with 4 to infinity. Okay, let's look at one application type problem, and then we'll call it quits. So we're given a position function, so quadratics are often used to model projectile motion, -16x squared plus v sub 0 t, that's my cursive v, and that stands for initial velocity, plus s sub 0, and s sub 0 is for initial position. Okay, this is a standard formula. If you took physics, you would see this formula, and it describes the motion of a projectile. So, a long time ago, people were looking around in reality and noticed when you throw something, it kind of has a geometric description. It always goes in like a parabola. Okay, and then that started like the whole math revolution, I guess. So anyways, v sub 0 is the initial velocity. S sub 0 is the initial position. So basically the position at time 0. And then t is for time. And then s of t is your position at time t. Or in this case, height at time t. Okay. If you keep taking math, you probably want to take some physics. The two are so intertwined with each other, you're going to be forced to deal with it. Okay? So if you want to take calculus and that sort of thing, you probably should be taking physics as well, in my opinion. Okay. So in this scenario, we have a ball that's being thrown straight upwards. From a rooftop, which is 160 feet high. With an initial velocity of 48 feet per second. If you watch baseball, they'll talk always about the initial velocity of the ball leaving the bat. Like last night, or maybe 2 nights ago, Slamtana hit the ball, and it was like 104 miles per hour velocity off the bat. Okay, they always talk about that, and they're talking about physics. Okay. So anyways, during what time period is the ball above the roof? Okay, so let's leave this thing out. Let's draw a little picture. Here I am on top of this roof, and I throw the ball up. The roof is 160 feet high. Okay, so for our formula, we need the initial velocity and the initial position. So the initial velocity is given as 48 feet per second. And then the initial position, well, that's just the height of the building. We'll not think about, maybe an extra 5 feet for the height of the person. Just the height of the building is good enough for our unrealistic scenario. Okay. Okay, so now I can write out my formula based on this, S of t. So S of t is going to be negative 16t squared plus 48t plus 160. And then the question's asking what time period is the ball above the roof? In other words, when is, so the question really asks, when is S of t greater than 160? In other words, we have a polynomial inequality that we need to solve. Right? So if we write it out, it's negative 16t squared plus 48t. When is that greater? Whoops, getting ahead of myself. Plus 160. When is that greater than 160, right? Okay, so we need to set it equal to 0. So move the 160 over. 16t squared plus 48t. When is that greater than 0? I need to find the boundary points, so I'm going to set it equal to 0 and sort of solve out. So I think I can factor out on a negative 16t, okay? And then I'll be left with t minus 3 equals 0. Okay, so there's two zeros here. There's 0 and negative 16t equals 0, so in other words, when t is 0. And then when t minus 3 equals 0, in other words, when t is equal to 3. Okay. So then I can do my number line. And I have 0 and 3 here. And do my test values, my signs, and my conclusions. So test value, this isn't going to work, right? When and these should be t values, right? Because we'll not worry about time being negative in this, but for the completion of the problem, let's go ahead and do it just for. So t equals -1 is kind of, no, that's not going to work. We don't have negative time in our reality. But we'll do it anyway. So, okay, so where am I plugging this thing in then? I'm actually plugging it in right here. So negative 16 times -1 is positive, and then -1 minus 3 is negative, so positive times negative is negative. So that would be where it's less than. We're not going to use that part anyways. Then t equals, try 1. Negative 16 times 1 is negative. 1 minus 3 is a negative. Negative times negative, positive. So that's where it's above the roof. Try t equals 5. Negative 16 times positive 5 is negative. 5 minus 3 is positive. Negative times positive is negative. So then it's below the roof. Okay. So our solution set is where the stuff is above the roof, and that's just this middle interval. Solution is the solution set, rather, is the interval from 0 to 3, and we don't include the endpoints because of that inequality type. We want to know where it's above the roof, not where it's above or equal to the height of the roof. Okay, okay, so the solution set is 0 to 3. In human terms, we also want to interpret our answer into a human setting. The ball will be above the roof for 3 seconds after it's thrown. Okay. Okay, and that'll do it for us. Thanks for watching, and we'll see you next time.